Okay, question 2 here. Let's get into it. So the first thing we're going to do is read the question. Question 2. A researcher believes that on average the population is greater than 80. The population standard deviation is known to be 12.9, and a random sample of 200 data points is collected, giving us a sample mean of 83.1. The hypothesis test carried out with a significance level of A equals 0.1. That's 1%. That's the 1% level. So the first thing is, I've got to write down the null and alternative hypothesis clearly. So the researcher believes that the mean is greater. So he believes that the mean is greater than 80. So my null hypothesis, my HO, is going to be where the mean equals 80. That's what we're saying here with this, and it says it here. It's greater than 80, so we're going to say it equals 80. Now the alternative hypothesis, H1, that's going to be that this here mean is greater than 80. Because he believes that it's going to be greater than 80. Now, so this is a right-tailed said test. So let's compute this test score and do the rest of it here in this part. So we're going to test this here, do the test statistic. So the first thing is I'm going to write down what sigma equals, and that equals 12.9. We read it in the question. The sample size equals 200, again from the question. We've got x bar. Now x bar is the sample mean, which is 83.1. Then we've got the hypothesis mean, which equals 80, and we've got alpha, which is our 1% or 0.01, the significance level alpha. We go to our calculator over here, and we're going to put all of this into this calculator, and we're going to go into inferential statistics, which is this one, inferential. Press OK. Now we've got tests to do. We're going to go down and do a test, and we're going to do a one mean test, and this is a said test. So here we go. Now, what our null hypothesis is, it is 80. So put in 80 here, press OK. Now we want it to be, this says less than, and you can see here it says less than in the calculator. We want it to be greater than 80. That's what he thinks is happening. So we're going to press OK here, and we're going to scroll down and make it greater than 80. Then scroll down to next. We're going to input the stat data. So x bar, that's 83.1. X bar, 83.1, sample mean. So we're going to put in here 83.1. 83.1, press OK. The sigma, which is 12.9, put in 12.9, press OK. Sample size, 200. Let's stick in 200. Okay, and our significance level is 0.01, 1%, 0.01. Press OK, then press next. So now we've got two bits of information here. We have got a said value and a p-value. We're going to put both of them down for this, the p-value and the said value. And you can see it's down here as the p-value has to go. So I'm going to put firstly my said value down. And here we can see that said, I'm going to just round it up to two decimal places, 4.0, and our p-value, the p-value in this box, that equals, and you can see there it's like 3.3 by 10 to the negative 4. That means we're going to bring this, if we put loads of zeros here, we're going to bring this 4 places, 1, 2, 3, 4, this way here. So our answer for the p-value is going to be, write this down, 0.1, 2, 3 zeros and a 3. That's the p-value. Now we're going to make a decision here. This is the next question. Now with the p-value, that p-value was 0.0003, and that is less than 0.01. This here is alpha, or significance level, which is 1%, and this here is our p-value here, and we know that's less than it. So what this means is this means that we are going to reject the null hypothesis. So we're going to reject the null hypothesis. or you can say HO. HO. Now, there is strong evidence to support the claim that the population mean is greater than 80. So we just say evidence to support the claim that the population mean is greater than 80. Now, obviously, if this was the other way around, and you had a bigger number here, like 3, well, 0.9, and that is this way around, then we'd fail to reject. But when it's smaller, when the p-value is smaller than the significance level, we reject the null hypothesis. Now, let me just go into that in a bit more detail. The p-value, this p-value here, is the probability of getting a test statistic that is if HO is actually true. Now, the z-score, so the z-score is tells us how far our sample mean is from the hypothesized population mean. So how far away is it from there? But anyway, that's us done. Thank you very much for watching.